Euclid is going to be the big cosmology space mission of this decade. If you're a researcher working in Europe and you're interested in cosmology, you definitely want to be in Euclid. I'm Julian Adamek. I'm an SNSF Professor at the University of Zurich doing cosmology at the Institute for Computational Science.
Euclid is a space telescope, ready for its journey into space. It will scan the sky, mapping the whole universe, showing the unprecedented huge amount of galaxies, and bringing light to dark matter and dark energy. It will reconstruct 10 billion years of cosmic history. Euclid is an ESA mission. UZH scientists are part of the Science Working Group.
Humans have created maps of the world around them since the dawn of civilization. With Euclid, we want to create the most accurate map of the universe ever, charting even the most distant galaxies that we can see. So the distances involved here are so vast, they are very hard to imagine. Even a whole galaxy becomes just a tiny little dot in this huge three-dimensional map that Euclid will create. The distribution of these tiny little dots produces a distinct pattern that is generated by the forces of gravity that pulls the galaxies in different directions while the universe expands at the same time. As cosmologists, we want to examine this pattern and learn something about these forces that are at play. And if we understand these forces well enough, we can also build them into computer models and try to simulate the evolution of the universe and see if we can recreate these patterns. One of the challenges in the simulations is that we have to tackle a huge range of scales in terms of time and space. Every galaxy is just a little dot in our simulation, but it's of course a very complicated object. There's a lot going on inside, but we want to spare us the details without losing too much accuracy. Another challenge is that while we are looking far out in the universe, we are also looking back in time because light needs a lot of time to cross these vast distances. And also light is not immune to gravity. It gets slightly deflected along its way because there are masses that changes its path. So that will also have a small effect on the distribution that we observe in the sky and needs to be taken into account. So here we are trying to play some kind of imitation game. We simulate how the universe evolves, and we try to see if we can actually recreate the patterns in the same way as we see them in the real universe. And the more these patterns match our observations, the more confidence we have that we understood something about how the universe works. These big numerical simulations for us cosmologists are what the research laboratory is for every other physicist. So we use the supercomputer as our experimental apparatus, where we can simulate the evolution of the universe, and we have full control over all the parameters, just like an experimenter would have in the laboratory. I've been a member of Euclid since 10 years, and in the last 2-3 years, the activities became much more intense while we were now gearing up for launch. In particular, I was involved in making sure that our simulations and our numerical methods are really up to the task. Once the data arrive, we need everything to work. So Euclid is going to be launched very soon. So everyone is of course very excited and hope that it goes well. But there's a lot of work we still need to do. Yeah, we are very busy preparing.
Euclid will be launched in July 2023 and travel to its destination, the Sun-Earth Lagrange Point 2, 1.5 million kilometers away from Earth. The first raw data from Euclid is expected to be available in 2024.